So today's notes are going to be about the triangle inequality theorem. Let's take a look at this theorem visually before we even write down what it means. The triangle inequality theorem basically says that the two shorter sides of the triangle have to be longer than the third side when they're added together. So you could see from this image, when we stop this, there's no way that you can create a triangle with sides of length 2 and sides of length 3 if the third side is 20. They're just not going to close. This makes me think of Tyrannosaurus Rex. He can barely close his arms together because they're so short. So if you go back to this sketch, you could see that those sides aren't going to make a triangle. Now let's take a look at another example where you've got the sides 14 and 6, and together the two smaller sides, 14 plus 6, they add up to exactly 20. But if we animate these points, what we're going to see here is that you still can't make a triangle because these guys, they close and they don't make it to be able to touch each other unless it becomes flat and there's no triangle. So the bottom line is that the two shortest sides, in this case 12 and 10, have to have a sum that's greater than the largest side, 20. So here, if we animate these points, these sides could close, and if they were going to make a triangle, they would intersect right here and right here. So now let's go ahead and take a moment and write down the triangle inequality theorem. So here is the triangle inequality theorem. You're going to want to pause the video and write this down in your notes. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Let's say you were given three sides of a triangle, 3 centimeters, 8 centimeters, and 5 centimeters. What you want to do is you want to take the shortest two sides to determine if it's a triangle and add them up. The biggest mistake that people would make here is that they would say, all right, 3 plus 8 is going to be greater than 5. But you can't do that. You have to take the smallest two sides. So you've got your 3 centimeters and you've got your 5 centimeters, and you want to take 3 and 5 and add them together and determine if they're greater than 8. But they're not greater than 8, and so this does not form a triangle. Let's take a look at a problem like this. What's the range of lengths for the third side of a triangle if the first two sides are 7 centimeters and 10 centimeters? Well, let's just sketch a random triangle and let's put in some side lengths. We've got 7 centimeters and we've got 10 centimeters, and the question is, what are possible lengths for the third side? So take a minute to write down this problem and sketch the drawing, and then we'll talk about how to go through it. So the first thing we're going to do is we're going to assume, just to start out for the sake of argument, that the smallest side is x. And let's talk about the values that x could be if it's the smallest side. And if x is the smallest side, then it has to be smaller than both 7 and 10. So let's talk about possibilities for x if it was an integer, a whole number. We've got 1, 2, 3, 4, 5, and 6. I know there's a bunch of numbers in between those numbers, but we're going to make the discussion easier by just focusing on integer answers. And then we'll clean it up at the end. So let's take a look at these answers. Is it possible for the third side to be 6? Well, if you took the sides 6 and 7 and added them together, would they be bigger than 10? And the answer is yes. So 6 is a possibility for the third side. What about 5? Well, you take 5 and 7 and add them together. They're also bigger than 10. You take 4 and 7. You add them together and you get 11. So they're bigger than 10. Now when you get down to 3, you take 3 and 7 and you get 10. So 3 doesn't work because 3 and 7 together are not bigger than 10. And as it turns out, same thing with 2. 2 and 7 are 9. That's not going to be bigger than 10. And 1 and 7 is 8, so that's not going to work either. So now that we know that 1, 2, and 3 don't work and 4, 5, and 6 do work, what about a number like in between 3 and 4, like 3.1? Well, let's take 3.1, for example, and add it to 7. And when we do that, we get 10.1. And 10.1 is not much bigger than 10, but it is bigger. So 3.1 would work. So what we find out is that everything that's above 3 works, no matter how much bigger than 3 it is. It could be just 1/100th or 1,000th bigger than 3. As long as the third side in this case is bigger than 3, it's going to work. Now, for a shortcut, take a look at how 10 and 7 relate to each other. If you took 10 and subtracted 7, you would end up with 3, the bottom value. So we now know the lower end of the range for the triangle. It has to be greater than 3. Well, let's now take a look at the upper range of what the third side could be. So at first, we assumed that x was going to be the smallest side of the triangle, and now we're going to do the same thing. We're going to assume that x is the largest side of the triangle. So let's take a look at some numbers, some integer answers that are bigger than 10, because now x has to be the biggest side or the longest side of the triangle. So we've got 11, 12, 13, 14, 15, 16, 17, 18, 19, and we'll stop there. So let's go through these quickly. Let's say we take 11, for example, and we find out that the two smallest sides are now in the triangle, 7 and 10. 7 and 10 are bigger than 11, so they make a triangle, so 11 works. 7 and 10 are bigger than 12, so that works. And you're going to find that 7 and 10 are bigger than all of these. And then when you get down to 17, you notice you would then have the three sides, 7, 10, and 17. And the two smaller sides in this case are not bigger than the biggest side, so 17 does not make a triangle. Same thing's going to happen for 18. You take 7, 10, and 18, and you're going to find that the two smaller sides are not going to be greater than 18. 18 is not going to work, and for the same reason, 19 is not going to work. Then we're going to take something in between 17 and 16, like 16.5, and let's test those numbers out. If you take the two smaller sides, 7 and 10, when you add them together, are they greater than 16.5? And the answer is they are. So the way this is going to work is just like the smaller values, when you subtracted 10 and 7, you're going to take 10 and add it to 7 and get the number 17. And 17 does not work, but everything that is less than 17 does work. So 16.9999999 would work as long as it's smaller than 17. So now you know the values for the third side of the triangle. You know that the values have to be bigger than 3, but they also have to be less than 17. And everything in between will work. So the way you do this to write this as one inequality statement is you put an x down and you put two symbols going both the same direction. And now we're going to translate this into this first part where x has to be bigger than 3, but then it also has to be less than 17. So the range of third sides would be greater than 3 centimeters while simultaneously less than 17 centimeters. And that's how you do one of these range of the third side problems.